Good afternoon everyone. So friends, in our last lecture we have seen the introductory part of rotational dynamics, some basic concept related with physics, especially force and motion. So a small or quick recap. Force, it is the physical quantity which changes or tends to change the state of rest or state of uniform motion depending upon nature, whether it produces motion or it cannot produce motion. There are two types of force. One is unbalanced, which is capable of producing motion, displacement, and second is balanced, which cannot produce any type of displacement. Then we have studied mechanics and some related concept with the force, displacement and different types of motion. Especially our aim is to study rotational dynamics, that is rotational motion of object. But as per your syllabus, the 12th standard first chapter, rotational dynamics, it is actually a combination of two parts. One is small part of circular motion and second is actually rotational motion. So it must be clear some concept regarding the circular motion and some concept regarding the rotational dynamics, which actually we have studied in last standard. So there are few concepts which must be cleared again. मित्रांनो, तुम्हाला असं वाटू शकतं की 2-2 तास इंट्रोडक्टरी पार्टमध्ये कसे. मुळात फिजिक्स सारखा विषय समजण्यासाठी कन्सेप्ट तुमच्या फार क्लिअर पाहिजे. बेसिक गोष्टी एकदा का बेसिक गोष्टी क्लिअर झाल्या तर मग तुम्ही सहज पुढे चांगल्या प्रकारे जाऊ शकता. आपली अडचण अशी असते, आपल्याला सर्व काही चॅप्टर शिकायचं असतो पण त्याच्याशी रिलेटेड महत्त्वाच्या कन्सेप्ट, आपल्या महत्त्वाच्या ज्या कन्सेप्ट असतात त्या क्लिअर नसतात. आपण तो थोडासा वेळ देऊ. एकदा तुमच्या ह्या गोष्टी क्लिअर झाल्या, एकदा तुम्हाला समजलं की प्रत्येक वेळी त्या कन्सेप्ट आल्यानंतर तुम्ही त्या सहज समजून घेऊ शकता आणि पुढचा भाग तुम्हाला इझिली समजेल. त्यासाठी हा थोडासा वेळ आपला जाईल, याच्यात काही हरकत नाही. पण एकदा क्लिअर झालं की मग पळायला आपल्याला हरकत नाही. ओके. तर कालची शेवटची कन्सेप्ट होती आपली सेंटर ऑफ मास. सेंटर ऑफ मास ह्या काही गोष्टी आहेत की रोटेशनल डायनामिक्समध्ये याच्यावर खूप महत्त्वाचे प्रॉब्लेम्स येतात. न्यूमरिकल्स, these are the very important concept related with rotational dynamics. Especially last concept was again a rigid body, and the rigid body is having this concept called a center of mass. Any body, center of mass is the point in the body at which total mass of the body is supposed to be concentrated in order to explain its motion. Whatever may be the type of motion, that motion must be studied under the concept of this center of mass. If you know, if you get clear this concept, center of mass, then we can study any type of motion. Let us see. This is an object. This object has particular mass. Can we hold this object at any point instead of its center? This is actually center of this object. This can be balanced at this point only. If I displace my hand, the point of contact, at any other place, this object will fall down. Means this object can remain steady on the tip of any object, or we can consider this hand only when the hand is kept at its center of mass. So what is center of mass? The center of mass of any object, especially rigid body, is the point in the body at which its total mass is supposed to be concentrated in order to explain its motion. How we can explain the motion according to center of mass? You might have familiar with the game, what we call in Marathi as Vitti Dandu. If we apply force on that small piece of wood at the center, that small piece called as VT will move in forward direction at very long distance. But instead of applying force at the center of exactly center of that object or that piece of wood, if we apply force at any another place, it cannot cover that much distance as it has covered in initial condition. लाकडी विटीवर जेव्हा आपण एक्झॅक्टली सेंटरला फोर्स लावला त्यावेळेस त्यानं जितकं अंतर कव्हर केलेलं असेल तितकं अंतर ते दुसऱ्या कुठल्याही बाजूला फोर्स लावला कव्हर करू शकत नाही. म्हणजे एखाद्या ऑब्जेक्टला जर प्युअरली लिनियर मोशन पाहिजे असेल तर त्याच्या कुठे अप्लाय करावं लागेल फोर्स आपल्याला सेंटर ऑफ मासवर. आणि सेंटर ऑफ मासच्या व्यतिरिक्त जर तुम्ही फोर्स अप्लाय केला त्या बॉडीची मोशन ही ट्रान्सलेशनल किंवा लिनियर असू शकत नाही. It may be combination of translational rotational or it may be only purely rotational. The torque, the concept related with rotational motion, you have to study later on. So center of mass decides the type of motion and it gives us a point at which we must apply the force so that the body gets purely translational motion. And if we apply force excluding center of mass, the motion of that object may be rotational or just combination of rotational and translational. So center of mass, it is the point in the body at which total mass of the body is supposed to be concentrated in order to explain its motion. For any geometrical object which is having regular shape, the center of mass is its geometric center. Suppose this is the circular disc, it must be uniform. If the disc is uniform, then its center of mass is exactly at the center. Suppose this is a uniform rod of 50 centimeter length. This rod is uniform. It may be metallic, it may be wooden, or it may be made of any other material. So it has uniform mass throughout its length, then its center of mass lies exactly at the center. So for any object, rigid body which is having definite shape, pure geometrical shape, its center of mass is exactly at its geometric center. Not necessary for every object it must be its geometric center. Sometimes it may be the point excluding its geometric center. Instead of this rod being made of uniform material, if it is made of two parts, one is wood and second part is suppose steel or iron. Now what happens to center of mass? Exactly, the center of mass would be moved towards the side of steel. Why? The weight of this side, in another words we can say that mass concentrated in the side of steel rod is more as compared to that on the side of wood. Therefore the center of mass gets shifted towards the side of steel. म्हणजे जर जोपर्यंत एखादा ऑब्जेक्ट युनिफॉर्म असतो आकाराने तेव्हा त्याचं सेंटर ऑफ मास हे एक्झॅक्टली जॉमेट्रिकल सेंटर असतं. पण जर तो युनिफॉर्म नसेल थ्रू आउट इट्स लेंथ, थ्रू आउट इट्स शेप, आता त्याचं जे सेंटर ऑफ मास असतं ते जॉमेट्रिक सेंटर सोडून असतं. कुणीकडे जाईल ज्या बाजूला त्याचा मास जास्त असेल त्या बाजूला त्याचं सेंटर ऑफ मास सरकतं. सर ही एक महत्त्वाची कन्सेप्ट आहे सेंटर ऑफ मास, आणि हे डिसाईड करतं की एखाद्या ऑब्जेक्टची मोशन कशा पद्धतीची असावी. आणखी त्याची कन्सेप्ट येते सेंटर ऑफ मास ऑफ टू पार्टिकल सिस्टम. एक मॅथमॅटिकल रिलेशन आपल्याला तयार करायचं हे फार महत्त्वाचं आहे. सेंटर ऑफ मास ऑफ टू पार्टिकल सिस्टम. त्याच्यात जो फॉर्म्युला आहे ना त्याच्यावर तुमचे खूप महत्त्वाचे न्यूमेरिकल प्रॉब्लेम्स असतात. स्पेशली जे ऑब्जेक्टिव्हच्या एक्झाम तुम्ही देणार MCQच्या, नीट असेल, JEE असेल, तुमचे CET असेल, आणखी कुठली, त्या सर्वांमध्ये याच्यावर खूप वेळा प्रश्न असतात. म्हणून हे कन्सेप्ट फार महत्त्वाच्या क्लिअर व्हायला पाहिजे. या 11वीला थोड्याफार प्रमाणात होतं, तिथे मोजका पार्ट दिला, बेसिक कन्सेप्ट त्याच्यात नव्हती. इथं तुमचं हे क्लिअर होईल थोडक्यात. So center of mass of two particle system. Consider two particles of masses, suppose m1 and this is m2. These two masses are separated by small distance. We consider a coordinate system. This is x, this is y, and this is origin. Draw the position vector of two masses. This is position vector of mass m2 and this is position vector of mass m1. Suppose this position vector is r1, this position vector is r2. Join these two masses. Now these two masses are joined by imaginary line. These two masses are having their individual existence. Now we have to study the position of center of mass of these two particle system. Here we consider two particles of masses m1 and m2 separated by small distance. Now we have to find out the position coordinate of their center of mass. Consider here it is the center of mass. This is center of mass of this two particle system. Now draw a position vector of center of mass. This is position vector of center of mass. We can consider geometrically the position vectors, position coordinates of center of mass m1 are x1, y1. Position vectors of mass m2 as x2, y2, and position vectors of center of mass as x, y. We can write this position vector in terms of their position coordinates. That is small r1 is equal to this x1 into unit vector I, which is along x-axis, plus y1 into position vector j, unit vector j. Similarly, position vector r2 can be written as x2i plus this y2j. And finally, the position vector of center of mass having position coordinates x, y. It can be also written as capital R is equal to capital X into unit vector I plus capital Y into unit vector J. We have to find the values of x and y, which are position vector of center of mass. There may be number of problems regarding the regular shaped bodies or irregular shaped bodies in terms of this position coordinates. So, by applying the moment of mass in this system, the law of moment of mass in this system, we can write the mass concentrated at center of mass m1 plus m2 into position vector r equal to individual mass m1 and its position vector r1 plus m2 and r2. Finally, we can write position vector capital R is equal to this m1 r1 plus it is m2 r2 divided by total mass m1 plus m2, which is concentrated at the center of mass. We have to find position vector of center of mass capital R. This is called as law of moment of mass. So total mass at center of mass into its position vector equal to individual mass m1 its position vector r1, individual mass m2 its position vector r2. Now we have to solve this using the values of position vectors. Let us find the position coordinate of center of mass. So we can write this as capital R vector R equal to this m1 into actually position vector r1 in terms of its position coordinate is x1 unit vector I plus y1 unit vector j plus second part is mass m2 into its position vector r2 in terms of position coordinate x2 unit vector I plus y2 unit vector j total divided by m1 plus m2. Now we can separate these parts we have to solve this. So we can write this as vector capital R, position vector R. It is m1 x1 I plus m1 y1 j plus m2 x2 I plus m2 y2 j, and total divided by again is m1 plus m2, which is total mass concentrated at point called as center of mass. So here is a common term, unit vector I. Here is also unit vector I. In this case, a common term is unit vector j, and here is again j. You can take unit vector I common, unit vector j common, and separate this denominator also. So finally, we can write capital R equal to unit vector I is common. So in bracket it is m1 x1 plus it is m2 x2. Total divided by this denominator m1 plus m2 into unit vector I. Similarly, here j is common, take it outside the bracket. So it is m1 y1 plus m2 y2, outside the bracket is j, and here we can write m1 plus m. So see here clear, but capital R is equal to, we have capital R equal to capital Xi plus Yj. Here you can write, therefore capital Xi plus Yj is equal to this total part. It is m1 x1 plus m2 x2 divided by m1 plus m2 into unit vector I plus m1 y1 plus m2 y2 divided by m1 plus m2 into unit vector g. See on both sides of this equation. Here is x, here is unit vector I, here is also unit vector I. So you can equate the coefficient of unit vectors I and j on both sides. So finally you can write capital X equal to, what you can write capital X equal to m1 x1 plus x2 divided by m1 plus m. In general, for number of masses, we can write this as capital X equal to summation of mi xi divided by summation of m, or you can write this directly as total mass of the system. Similarly, y coordinate of center of mass is equal to m1 y1 plus m2 y2 divided by this m1 plus m2, and it is only for two particle system. If we generalize this for n particle system, we can write this as y equal to summation of mi divided by capital M, where I equal to 1 to n, here also I equal to 1 to n for n particle system. Instead of this system being system of two particles, if this system consists of number of particles m1, m2, m3, m4, m5, so on, for such system the center of mass has coordinates capital X equal to summation of mi xi, product of number of masses with its x coordinates divided by total mass of the system m1 plus m2 plus m3 plus m4, so on, and this y equal to like this. So you can write this for 3 particles, 4 particles, so on. Similarly, you can write also z coordinate if we consider this system as 3 coordinate system. It is only 2 Cartesian coordinate system consisting of 2 coordinates. If we use 3 coordinates x, y and z, then we can write also z coordinate. What will be the z coordinate then? Right, z coordinate will be summation of mi, yes, zi from I equal to 1 to n divided by capital M. So this is the very important formula related with center of mass of two particle system and its generalization. We have to use this formula many times for solving numerical problems, not only in board exam but also in the competitive, that is MCQ type of exam also. So in 12th standard this formula is not included, but you cannot bifurcate now the 12th standard syllabus and 11th standard syllabus. It is same now. You have to study 11th also, 12th also, if you are dealing with the competitive exam, that is MCQ type of exam, enter different entrance exam. So these are the position coordinates of center of mass of the system consisting of two particles. You can generalize this for n particles like this. So just I would like to give one two examples in which manner you will face the numericals related with this formula. So there are number of numerical examples you will face in different type of exam related with this center of mass. Some may be in general, that is for regular bodies, and sometimes they may be in terms of the irregular or different concept along x, along y and different axes. Just I would like to give one example here. Consider here a square frame. There may be a numerical problem. Consider here a square frame having its four corners holding the masses m1, m2, m3, m4, so on. So there may be a specific information given that you consider this as origin and then find the center of mass of this system. This side may be of 1 meter or of another length dimension. So for such system we can apply this formula m1, x1, m2, x2, so on. We can write like this. Suppose this is Cartesian coordinate system. This is x, this is y. Can you tell me the position coordinates of different masses? For m4 it is 0, 0. For m1 it has y coordinate 0 and x coordinate is 1. 1, 0. What about these? 1, 1. What about m3? Its x coordinate is 0 and y coordinate is 1. If this square has each side of length 1 meter, if this square has each side of length 2 meter, then these coordinates will be this 0, 0, this is 2, 0, this is 2, 2, and so on. Now the coordinates are known, the masses are known. If masses are given equal, then it will be very easy, and if masses are different like 1, 2, 3, 4, we can apply the formulas. The same example can be taken in case of rectangle, in case of triangle. If we consider this as a triangle, suppose one triangle is there, one corner is facing or one corner is coinciding the origin. So there are masses, suppose m1, m2, m3. We draw here imaginary line. Suppose this is 2 meter, this is 2 meter, this is also 2 meter. Length of each side of triangle is 2 meter. Then we can take coordinates like this. So can you find the coordinates of masses m1, m2, m3, so on? For m1, coordinates will be 0, 0. For m2, position coordinate. First is this y coordinate. What about x coordinate? This is x coordinate. X coordinate is actually this vertical distance. So this is 1 meter. This we have to find using Pythagoras theorem. So you can find this coordinate using Pythagoras theorem. This is, suppose it is y or y2. This y2 square equal to, it is 2 square minus 1 square. We can find this. So position coordinate of this m2 we can find, and finally position coordinate of m2 is here is m3. The position coordinate m3 will be, its x coordinate will be 0 and y coordinate will be 2. So in this way we can find position coordinates of center of mass using the relations. So these are just two geometrical examples in this way the problems may be asked in different examinations. There are also another examples related with the center of mass. So center of mass, it is a very important concept related with rotational dynamics, and it was included actually in 11th standard syllabus. There is again one small concept, it may occur many times in front of you while studying the rotational dynamics, the center of gravity. Center of gravity. What is mean by center of gravity? These two concepts are actually correlated, center of mass and center of gravity. What is center of mass? Center of mass is the point at which total mass of the body is supposed to be concentrated in order to explain its motion. By applying force at center of mass, we can produce purely translational motion. And if we apply force instead of center of mass on any object, the motion can never be linear or translational. It may be combination of translational, linear, or it may be purely rotational, combination of translational, rotational, or purely rotational. So again one concept is the center of gravity. It is the point in the body through which total weight of the body is supposed to be acting vertically in downward direction. So this is an object of irregular shape. This object consists of number of masses m1, m2, m3, m4, so on, at different points. Each of these particles experiences force in downward direction due to Earth's gravity. This object m2 also experiences force in downward direction. This particle also experiences force in downward direction. This particle also experiences force in downward direction. So through the center of or any point through this body, its total weight is acting vertically in downward direction. That point is called the center of gravity of that object. So this body consists of number of particles of masses m1, m2, m3. Each of these particles experience its weight which is acting vertically in downward direction. So through the geometrical or apparent center of this object, its total weight is acting vertically in downward direction, and that point through which its total weight is acting vertically in downward direction is called its center of gravity. So this is center of gravity of the object. So center of gravity, center of mass. You may come across this concept in examples, numerical examples related with circular motion. That the vehicle is moving along the convex curve path. The height of center of gravity is given. We can find the speed of that vehicle. So this is the concept of center of gravity, center of mass, center of gravity. And one last concept related with this rotational dynamics is when we can start the actual syllabus of rotational dynamics. One more important concept is it is couple or torque. This is again an important concept. Actually, we have seen this in last lecture. Couple or torque. Couple itself suggests the name. Name itself suggests the concept. Couple means it is combination of two forces. But how? These two forces must be acting on the body at different points, but exactly in opposite direction. That forms a couple. It is. I want to give you a few examples. This is a bottle. You have to open this bottle. So can we do this by applying force by single finger? It is not possible. Like this. It will not open. How can I remove this cover? So I have to apply force using the two fingers, at least two, like this. In this way. So we can remove the cover using two fingers or more fingers, but applying force at different points. Again, one example. You may be familiar with this instrument. मराठीमध्ये आपण पाना म्हणतो. What is the use of this? To tighten the screws, nut and bolts. हे मोठे मोठे जे नट बोल्ट असतात त्याला लूज करण्यासाठी किंवा काढण्यासाठी वापरतात. कसं अप्लाय करतात हे? एका ठिकाणी इथं स्क्रू आहे त्याला असं फिरवायचं. ॲक्च्युली डायरेक्टली आपण स्क्रूला फिरवलं तर तिथं फोर्स कमी लागतो आणि याच्या मदतीने लावलं तर तेच कमी वेळेमध्ये आपलं काम करतं. ह्याला काय म्हणतात? This is called a screwdriver. What is use of this screwdriver? To tighten the small screws, especially in electrical pin and remaining that is instrument. So जिथे आपण ते छोटे छोटे स्क्रू हाताने बोटाने आपण फिरू शकत नाही तिथे आपण याचा वापर करतो. हे काय करतो? हे असं लावलं आपण आणि मग त्याला फिरवलं असं. इथं सुद्धा काय करायचं आपल्याला? दोन बोटाच्या मदतीने आपण फिरवतो. हे सर्व एक्झाम्पल आहेत कपल किंवा टॉर्कचे. कुठल्याही ऑब्जेक्टवर हे ऑब्जेक्ट आहे ह्याला आपल्याला रोटेशनल मोशन प्रोड्यूस करायचे. हे असेल त्याचं परपेंडिक्युलर डिस्टन्स आणि इथं अप्लाय केला आपण फोर्स. So this torque or couple, torque can be written as tau is equal to vector r cross vector f. This is a vector quantity. In magnitude, this torque can be written as only f into r. But in vector form, this torque is written as vector tau equal to vector r cross vector f, where r is the perpendicular distance between the point of that force and the center. Point of contact of force, line of action, you can see this as line of action and the center of that object. The distance, perpendicular distance between line of action and the center of the object is r. It is represented by position vector and this is a force. Now if we apply this force, this object rotates about its axis. So this is the origin of rotational motion. How we can produce the rotational motion in the body? Not by applying a single force at center, but we have to apply force at particular distance which must be perpendicular to the line joining the center of that object and the line of action of the force. So it causes the rotational motion in the object. To rotate an object, we have to apply this torque. There are properties of this torque or couple. The same figure can be extended like this. Using such forces also we can produce rotational motion in the body. मराठीमध्ये आपण ती भिंगरी म्हणतो फिरवण्याची. पाहिली कधी एखादं झाकण, आता हे झाकण फिरवलं, इथे काय केलं आपण, फोर्स असा लावला ना, हे असं एक बोट इकडं फिरवले, दुसरे इकडं फिरवले, म्हणजे या झाकणामध्ये कोणती मोशन तयार झाली, रोटेशनल, त्याला रोटेशनल मोशन. रोटेशनल मोशन प्रोड्यूस करण्यासाठी कपल यूज करते. कपलची महत्त्वाची प्रॉपर्टी असते, कपल प्रोड्यूस प्युअरली रोटेशनल मोशन. टॉर्क ऑल्सो प्रोड्यूस रोटेशनल मोशन and couple also produce rotational motion. So couple and torque are the same concept, you can say. So torque equal to force into perpendicular distance. Unit of this torque is combination of unit of these two, that is Newton into meter. If you try to write its dimensional formula, it is kilogram meter per second square into meter. So it is kilogram meter square per second square, means dimensional formula can be written as m to the power 1, m to the power 2, t to the power minus 2. It is similar to that of work. So torque and work or energy are the quantities having same dimensions. So this is the introductory part of rotational dynamics. We cover this through the complete, actually the required syllabus from 11th standard and 12th standard. So this is the introductory part of rotational dynamics. In next chapter we will start actual rotational dynamics with some concept regarding the circular motion of the object.